Hi, so this is our lecture 2 of module 1. Okay, in the last lecture we saw some part of it, right? Means what is meant by over voltage that we particularly see, and we also saw the need for high voltage, right? So in this lecture we will move on to the different other cases of over voltage. In the last class we saw different types of over voltage. Like in power system over voltage, there are two types: internal over voltage as well as external over voltage. And in internal over voltage, there are two types: temporary over voltage and switching over voltage. And external over voltages are caused by what? By the atmospheric disturbances. And lightning over voltage is an example for that, right? And in internal over voltage, we were particularly discussing about what? We discussed everything about the temporary over voltage, and now we will get into what is meant by the switching over voltage and the external over voltage. So this is what we are going to cover at first. Okay. So what is the peculiarity of temporary over voltage? In temporary over voltage, whatever that over voltage phenomena, if it happens, it will be there for some amount of time. So that is the peculiarity of temporary over voltage. When it comes to, we will see what is the difference when it comes to the switching over voltage, right? So according to IEEE standard, right, there are different standards all around. So these are used to classify, or these are used to tell us what I can say, standardize different definitions. So what is meant by switching over voltage, or we also call it as what? Surge, or also call it as what? Transient. It's a subcycle over voltage with a duration of less than half cycle of the normal voltage waveform. Understood? Means as the name implies here, switching over voltage means, as the name implies here, switching, right? Switching over voltage means what? Whenever you have a transmission line going on like that, whenever a switching operation happens on the equipment, whenever you have a switching operation happens on the transformer and anywhere it is, so at that time, whatever, like when you have studied in your RLC circuit basics, in your network theory, or in your basic electrical engineering course, that whenever you switch on or switch off a supply, and there are this RLC elements in that, then what will happen? Then transients will definitely occur, right? So that transients, such things which are what is the peculiarity of that? That's a subcycle event, like that happens for a small amount of time, and it will get damped out much more faster, right? So such a the thing is what we mean by what? Switching over voltage. Mainly it happens due to switching operation, right? So and the surge can be of either polarity, like it can be additive or subtractive from normal voltage waveform, and is often oscillatory decaying, right? We will see the example for this thing here. Okay. So what is meant by means, generally in any switching operation, as I said, like there is a fault initiation or the fault interruption, like we are opening an isolator. Understood? So under all these conditions, we can what will happen? Then this surge over voltages will happen. Okay. So and this sudden change in the system, it can initiate this damped oscillation. So and what will be the nature? As I said, when it comes to a transient, you have your inductances and capacitance inside, right? So it will be what the inductance and capacitance are there. Then it is not at the system frequency we are talking about. What is our system frequency? Power system frequency is 50 hertz, right? But yeah, there will be a frequency for what? There will be a frequency for your inductance and what? And you have shunt capacitance in your power system network. So combining this L and C, what you will have a resonant frequency. You will have a resonant frequency, and this transient response, this transient phenomena, whenever it occurs, then that will be what? Like your power waveform is going like this, and here you are switching it on. Then your transient phenomena will have a higher frequency component, which will what? Which will be what I can say, which will be taken out so faster, right? So it will be damped so faster. But this part of the wave, if you take, means this is the instant where you are switching it on or switching it off, whatever it is, or there is a sudden variation. Then at that time, you will have a higher frequency component, as I am showing it here down. So this will correspond to what? This will be determined from the resonant frequencies of the network. That is what I want to tell you. Then what? This oscillation frequency is typically of the order of what? Some 100 kilohertz. It is not in 50 hertz. That's as I just shown you. It will not be in 50 hertz, but it will be in the range of kilohertz. Understood? And the duration of the surge is situated over a much wider time range that is, we will see later. Okay. So just like temporary overvoltages, what are the causes here? Like temporary overvoltage means what? It can occur for some duration of time. But switching operation means it's a sudden event, like a fault occurrence. Suddenly it is happening, and it will not be sustained for a long time. It is for a small time interval. That is what is meant by switching over voltage. So large number of events can initiate. So one such, we will discuss one after another. One is what? Energization of the transmission line, right? One thing is energization of transmission line, right? You are as I said, switching on the supply, like that. So energization of the transmission line, or it can be a cable, or it can be a capacitor bank. Whenever we are energizing or we are just adding something new to the network, then it can cause transient because there is a switching operation involved. Then what? So some of them are like in the open circuit at the some of the common switching operation is what? Or a line that is open circuit at the receiving end, then energization of a line that is terminated by an unloaded transformer, right? An unloaded transformer at the end, and then the energization of a capacitor bank, right? These are the three cases. Now, when we also should see the re-energization of a line. Like we isolated a line from the two side. Let me say, okay, there was some work going on, and you just isolated that transmission line from two ends. Okay, what do you think? Whether there will be some potential over the transmission line or not? The fact is that there will be, okay, and because of that, whenever you are again re-energizing this line into again, then what will happen? Then there will it can cause a transient, or it can cause over voltage and transient. So this is another thing that can cause what? The over voltage. Okay, now the third one is what? Third one is the switching on and off of an equipment, of any equipment, right? So it can be a high voltage reactor, or switching of the capacitor banks, or one switching of a transformer at no load. Transformer at no load. Okay. So these conditions can also be can happen in power system operation. Then it can be fault initiation and clearing, right? Whenever a fault is initiated, then what will happen? Your circuit breaker will operate. So these all principle you are going to study in power system, power generation, transmission, and mainly the protection part. So there it will become more clear to you. Okay, what I am just telling you the causes for what? The switching over voltage. When I say fault initiation and clearing, what is happening? Whenever a fault is happening, then your relay will understand that it will isolate the transmission line part, right, or the faulty part. So that that's a switching operation. So that is what is meant. Now even the commutation notches, it can happen, and the load rejection. We will see. We have already seen load rejection, right? So this can cause what? Even this also can cause the switching type of response. Understood? Switching over voltage can be caused by load rejection. Now, just for an example, I am showing you this. Let us say we are going to energize a capacitor bank. What is meant by energizing a capacitor bank? Energizing a capacitor bank is like this, right? So this RL circuit is already there, and that is your transmission line, right? This RL circuit is already there, and that is your transmission line. And let me say under that condition, without this capacitor bank, you have a supply voltage like this part here. You have a supply voltage as shown in this part here. Okay, so under that condition, now you want, let me say you want to improve the power factor of the supply, right? You want to improve the power factor of the supply, or that is why you are going to add a capacitor into the circuit. So whenever you are switching on this thing toward supply, as I said, it is an RLC circuit. So what then? Whenever you are switching on, or whenever you just switch on, then there will be a transient response involved, right, in an RLC. And definitely, yeah, now in this case, you are switching on at this instant. Okay, that is why your transient has started like this, and it is there what, like for over a half cycle period, that phenomena is happening. Okay, I made it so bad, so you can see it now more clearly, right? So at this instant, you are switching on the supply, so that what your transient happen like this till here, right, for a half cycle period. You understood? So this is an example for what? the transient response. When you have the other case like a load rejection case or something, or when you have what a temporary overvoltage, it means that you have a supply like this up to here, okay, and at this point some disturbance happened, let me say, then what, your voltage has raised a bit more, okay, my waveform might not be looking so good, but I think you are able to understand, raised a bit more, and it is taking some cycles at least, and after some time it comes back to normal level. So what is the difference here? In a switching over voltage, the event occurring for a smaller duration of time, while in a temporary over voltage, it is taking what, it is taking more time. Understood? It is taking more time, as you can see here. Okay, this thing is taking more time, okay, and this phenomena here, it is taking lesser time. So that is the major difference between temporary over voltage and the switching over voltage. Clear? Now even it can, if it is like a if it is taking some more time, let me say, okay, if we are having a slower switching process, then what will happen? Then as you can see here, if at all it's a slower switching process, as you can see here, what it started at this higher at this peak point, and it took some time, okay, so it will take more time, and you can see this is what, this is the one, let me say this is the voltage first, and your voltage is getting doubled, like even more than double when a switching over voltage is coming, okay. So that is what happens when a switching in a capacitor bank is energized, okay. So in this case, a slow process arcing between the contact occurs around the peak of 50 Hertz, because when it is slow, it is happening. So that is that. Now, so this is our discussion about what our over voltages. We will see more about in detail when it comes to module 4 on testing. So this is an introduction, and I just want you to understand what are the over voltages that comes into. So that is what temporary and and the switching over voltages, right? Due to internal causes, right? Internal over voltage. Now, the one external over voltage phenomena that we have is what, the lightning over voltage, right? So first the concept that we man understood long before is what, that lightning is electricity, and I think you might have seen this picture, right? You might have seen this picture all around long before, right? So this is Benjamin Franklin standing, and his helper or somebody, okay, whatever, and his kite experiment. The kite experiment is quite famous, right? So this is the picture of that. Like where he started seeing the sparks, like thunder, whatever he started seeing, like lightning and thunder. So this lightning he saw, and he felt that it might be electricity. So to prove that, Benjamin Franklin took a kite and like with silk, and he made it fly when it was very much cloudy and there was lightning, and he was able to store charge into the Leyden jar that is shown in this here. Okay, Leyden jar is an equipment to store charge used at that time. So he was used to, he did that, and even story goes this way that he even got shock. Okay, so the no, but like I don't know whether it is true or not. So that has happened even, but it is quite true that while doing experiment after years after Benjamin Franklin, another scientist was dead. Okay, doing experimentation on lightning like this. So whatever. So with this is known to people that lightning is also electricity. Okay. So why, as a high voltage engineer or as an electrical engineer, why we are this much interested in lightning over voltage? Because when you are lightning over voltage, or lightning, as you said, what lightning is an electric discharge. Okay, lightning is an electrical discharge between what, between cloud to ground, or even it can happen between cloud to cloud also. Even most of them will happen between cloud to cloud. So whenever it is comes, if it gets on to, this is the transmission line. Okay, I think this kind of poles are familiar for you, right? So this is a transmission line. Whenever it is striking the transmission line, then a high over voltage will be created over this transmission line. So in order to avoid that, what we do, in order to avoid that part, what we do is that you can see, okay, normally on every tower or every pole, like you can see, like if it can be like a phase and neutral, right? but it is not. There will be always another one more line, or if it is a three-phase line, like you need only how many, three phases and neutral, but you will have a fifth line going over the top of this pole. Like this is what we call as what, the ground wire. This is called as the this wire is called as what, this is the ground wire. Okay, so this ground wire, or this wire, that is where your lightning will directly come. Why? Because when lightning is seeing for a path, like your clouds are here and lightning is seeing for a path, it will definitely take the upper part, right? Not it need not come up to here. So that is how you are trying to save your transition line, and that is our interest. That is how we are more interested. Okay, it is because it is about the safety of the transition lines. And one major thing that we get into while discussing this ground wire protection is that this angle here means there is an angle, if the height of this ground wire is higher, then you get more of this angle, understood, right? You can have more area. So that comes into design, like how with how much angle you can protect your transition line. Okay, so let me say, like it's a 100 kV line, then normally it is 30 degree. This theta will be 30 degree. Like if your transition line is hanging out of this range, out of this 30 degree, and it is, let me say it is hanging here, then what will happen? Then this wire cannot protect you, understood? So that is what is meant, that is our interest. Okay, so and a practical application when it comes. So first let us see. So what I want to conclude here is this only. But this lightning cannot be prevented, right? We cannot prevent lightning. It is what, it's an external low voltage. We cannot do anything about it. And but it can be intercepted. The interception is how we can intercept is shown here, right? So how it can be intercepted is shown here by placing a ground wire over a transition line, right? So this way we can intercept it, just like we stay over buildings by keeping a lightning arrestor on top, right? So it can be intercepted, and this is done with the help of providing ground wire along a transition line. Understood. So ground conductor is a conductor that runs parallel to and above the phase conductors of a transition line. You got it? So some part is missing here because this figure is covering it. So this is transition line. Okay. So that is about the application of lightning over voltage. Now let us see just the mechanism. Okay, we will come into more detail afterwards. So during thunderstorms, what happens? Let me say you have a cloud, and in that cloud you have positive as well as negative charges distributed all over. But whenever your air currents, right? Whenever it is cloudy, whenever it is going to rain, or whenever there is nice air current going on, then due to that your positive and negative charges will get separated. And normally what happens, commonly the bottom layer will be negatively charged and the top layer will be positively charged. Okay, that is how it happens. Okay, the bottom will be negative and the top will be positive. Not always. Okay, most of the time it is that way. So lightning whenever that potential, let me say your cloud is here and this is your what point. Okay, so whenever it normally doesn't start like that, it will slowly happen, like ionization path will come from here to here to here, just like you can see here, right? It is not just what's directly coming out, so it is having a path. So after initiation, whenever the breakdown strength of air is loose, then or an ionization path is achieved, then a complete path is achieved, then you will see this lightning, or that is when you are having this lightning. Okay, the phenomena we will see in detail afterwards. So lightning strokes are generally of what, negative polarity, that is negative cloud and the positive ground, right? So if it is a cloud here, so your negative polarity is all on the what, bottom side, so and positive on the upper side, right? So because of that, normally what your polarity will be what, negative only, because this negative side is more closer to ground. So lightning strokes are generally of what, negative polarity, that is negative cloud and positive ground. Now roughly 10% have reverse polarity, that a possibility also is there. And frankly, the main interesting part is that most of the times the lightning is happening between the clouds, like you have a cloud here and here, or even between the charge centers. That is where lightning mostly happens. Okay, now and some amount of it between what, between the ground and the cloud. So this is what is happening. So that is the mechanism once again. If we see as a separation of charge proceeds in the cloud, then the potential difference between the centers of the charge increases and vertical electric field within the cloud also increases. So that is what happens. And interesting part is that the net potential difference between the two main charge centers may vary from 100 to 1000 megavolt. Okay, 1000 megavolt. Megavolt means what? 10 power 6. So that much. Or I think you are able to understand. So that much high voltage will come between what? Between this charge centers. Okay, like between the cloud and the ground. So that is that much high voltage is coming onto your transmission line or onto your equipment, and that is why you want to protect it from lightning. And one way we discuss, there are several other things like lightning arrestor and all. Okay, so that we will come to that discussion later. Only a part of the total charge is released, as we already discussed. It is released to earth by ground lightning strokes, while the rest is discharged in the inter cloud strokes. So this we discussed already, and yeah, that is just general knowledge. Now we are going to discuss about the testing voltages, like high voltage testing voltages. Okay, so that is the discussion what we want to discuss now. I think you are able to see a building here, right? Can you say what is interesting about that building? As you can see, cars are there in front, then you have one floor, then you can see the second floor, but above the second floor it is just a huge cover, all right, because that is the height that if you get in, this is what, this is CPRI, Central Power Research Institute, Bangalore. Okay, their high voltage lab is shown in this figure. So after this two floors, then it directly you can see the floor height, right, like the height of this what I can say, like in a godown or even more than that. So such a big height, what is the necessity of that? Because you are going to deal high voltage testing, you are going to deal with very high voltages. Okay, you will see how much high, like why we are doing high voltage testing. Testing is done to ensure like whether a device manufactured or under operation, whether it is reliable or not. Like you have an overhead insulator, like and the manufacturer is saying it will be able to withstand 100 kV, right? So before installing it, you should be able to test it whether it is able to withstand 100 kV, and when it is like nominal voltage is 100 kV, definitely that is not what the insulation is going to face all the time. It will have over voltage, it will have switching over voltage, and even it can have what, lightning over voltage, right? So one thing I forgot to tell in lightning over voltage is that lightning occurs for a very small fraction of time, very small fraction of a second. Okay, so that is a different thing. So when in why we need high voltage testing, because we want to know whether our manufactured equipments or manufactured insulators or our equipments, whether they are able to withstand this high voltage, or before installation or commissioning. So that is the need for high voltage testing. So it is necessary to test the high voltage equipment during its development stage and prior to commissioning, right? So and the magnitude and type of the test voltage vary with the rated voltage of a particular apparatus, right? You think of this way, like when it comes to an overhead insulator, it will have a rated voltage, and the condition in which it is working will be different from a transformer bushing, understood, or any other equipment. Or when you want to test the cable installation, whatever its requirement will be comparatively different from an overhead insulator. So considering these facts, we devise high voltage testing in order to ensure that the device, the manufactured products, or before installation, we want to ensure that our products are working very nicely. So the major classification of types high voltage testing is done this way, like testing with power frequency voltages. Like normally our insulators or whatever equipments are there, they work on what, power frequency, whether they are able to work in that power frequency voltage continuously or not. So that is what our one first testing. Then testing with lightning impulse voltages. Lightning impulse voltages, like what we have already seen, lightning over voltage. So under such a lightning impulse voltage, impulse means a waveform like this, like when you see the lightning and whatever voltage is impressed on that, the waveform will come to like this, like it will have a peak like this for a very small fraction of time, like let me say 1.2 microsecond, and it will come slowly to 0, or come slowly down. Okay, so that is the impulse voltage. So that then what this that is the lightning impulse voltage. And even with the switching also, where we will try to test the testing with the switching impulse voltages also. Then what, testing with the DC voltages. So these are the four kinds of major tests that we will be conducting in a high voltage testing lab. Like, so one place where in India's what most sophisticated high voltage lab is one is in CPRI, Central Power Research Institute, where they conduct high voltage testing and research also related to this. So its high voltage lab image is shown in this figure. Now let us see what is meant by this testing with power frequency voltage. Okay, so I think you are able to see this voltage. When we speak of voltages, it is of this amount, like what, 600 kV. You can see the equipments also and the geometry also, right? In order to withstand this, and yeah, I think you are able to notice the height. Okay, it is like the inside that building, whatever you just have seen now. So that is the level of voltage we are working with. Because our transmission line or insulators, like what is the transmission level in India now? The biggest level is 765 kV. So already there is what, 100 kV or more levels are already there, and we want to test whether our insulators are working or our equipment will be able to work under this high voltage. To assess the ability of apparatus insulation withstand under the system's power frequency voltage, apparatus is subjected to what, 1 minute test. And how much voltage we need to apply? It will not be what, it will not be the normal power frequency voltage. It will be a bit higher than whatever voltage we apply. So that depends on how much higher it will depend on the country or where we are going to use it, and what kind of stresses it is undergoing. So decided based on that, we apply this power frequency voltage. Important part is that what, like our power frequency voltage is how much, 50 hertz, right? In other countries it is 60 hertz. So we just apply whatever nominal voltage, whatever be the nominal voltage that we apply for some time, but not nominal voltage, nominal frequency, but for an over voltage. That over voltage is decided based on different standards available. Okay. And when it comes to, like, all the equipments will not be installed indoor, right? Like we have a system, we have a transformer which is installed indoor, an indoor transformer, and we have an outdoor insulator also. So when it comes to an indoor system, then it will be tested indoor only, because your atmospheric conditions are not going to affect it much. But when it comes to an overhead insulator, then definitely your atmospheric conditions are going to affect. So for that, you will like what, standard rain as prescribed for appropriate standards. So that also we will consider when it comes to power frequency testing. Then the second part is what, testing with the lightning impulse voltage. You can see here, right? You can see this a big like what I can say, like a building inside a building, right? So that you can see here, right? So this is able to generate that high amount of like 1 megavolt. Such high amount of voltages impulse voltages will be generated with such kind of towers. Okay. So that is again it is inside it is an inside from CPRI. You can find the ratings in from CPRI website. So this lightning strokes terminating on a transmission line will what, induce the steep rising voltages in the line, right? Whose shape I draw in the last slides, right? So this exhaustive measurement and long experience have shown that what it has shown, that is shown that this lightning over voltages, the time that, like I already told you, right? So they have what, they reaches the peak value in 1.2 microsecond, and then decreases in what, around 50 microsecond, it comes down to the half its peak value. So such a waveform we create inside the lab, and we apply to our equipment and see whether it how the response is. Understood? So that is what is meant that done with the lightning impulse voltages. Now the similar thing can be applied to what, testing the switching impulse voltages, right? Now let me say it is 11 kV or a 33 kV or a 66 kV transmission line. Then definitely if you switch, let me say the 33 kV goes up by a small amount only when we are switching it. But that is not the case when it comes to 300 kV or 765 kV, right? Because their switching over voltage will be higher even compared to the lightning over voltages. So our interest, whether we should take care of the lightning over voltages or the switching over voltages, will depend on the voltage level. When it is lower voltage level, it means that we should be careful about the lightning impulse voltage. So on that, lightning impulse test will be done. But when it comes to a higher voltage level like 300 kV and above, or even like 500 or 765 kV, under that circumstances we will be concentrating on what, switching impulse test more than what, more than the lightning impulse, lightning impulse test, or the switching over voltage, because that will be huge even compared to this lightning over voltage effect. So that difference is there. And when it comes to switching over voltages, definitely the time where lightning is what, lightning is a very fast phenomenon, but when it comes to switching over voltages, it will take what, this 250 bar 2500 microsecond wave will be there. Like this is the, if this is the waveform, then what, the peak time will reach in 250 microsecond, and this time to reach will be what, 2500 microsecond, right? So when it was in lightning over voltages, this peak time was reached in what, it was reached in 1.2 microseconds. So that is the time difference here. Okay, and till now we were mostly this DC voltages, testing with high voltage DC. That was only kept inside like for research purposes. Okay, but now even this high with the advent in high voltage DC transition, even in the industry also people are very much interested in what, testing with high voltage DC, and that is what we are going to see in the next lecture, how to create, how to generate what, high voltage DC. Okay. So as I said, so even for testing DC voltage also, what we do is that I showed you one transformer, right? With a transformer you attach a rectifier, right? That is how we convert AC to DC. So that the same thing is applied, and they have application not only in like high voltage testing or just for electrical engineer. It has got application in different physical experiments, physics experiments also, right? If you are there are so many application when it comes to testing with DC voltages, where you need high voltage DC. Okay, so that in the next lecture what we are going to see is what, we will see how to generate the DC voltages, right? How to generate a DC voltage from AC. The simple answer is rectification, and we will see it. But in rectification we just are able to convert it to DC. We are thinking about making it to high voltage DC. So what will be the difference, that we will see in the next class. So I am so this is an image of high voltage testing. This is what you can, this is what really happens in the lab when a test is conducted. It is a beautiful thing to watch. Maybe one day you will see a high voltage lab, and hope you will have an experience on that. Okay, thank you for your time. Next lecture we will see DC high voltage DC generation.